some tangent line, right? We can get the slope of that tangent line from the derivative, okay? So there's my tangent line. Y prime equals its slope. Okay, that hasn't changed from way back in the early chapter 3 stuff. That's the same. What's new is here they're going to introduce us to the idea of a normal line. Okay, and we talk about them in this section. We'll never talk about them again, and in fact, you will never see them again until Calc 3, where you start drawing three-dimensionally, and we talk about tangent planes and normal planes. What a normal is a normal is the perpendicular to the tangent line, which means that it's also perpendicular to the curve. So that is my normal line, okay? The normal line is perpendicular to the tangent line. And because it's perpendicular to the tangent line, what does that also make it perpendicular to? To the curve also. So the normal line is perpendicular to the tangent line, and thus is also perpendicular to the curve. Okay? Now, if you know what the slope of the tangent line is, what kind of slope is perpendicular?
90.
Makes a 90-degree angle, so what about its slope? The relationship of its slope. Negative and the reciprocal of it. Okay? So if I know that, the red does not erase well. If I know that my tangent's slope is 2/3, what is the slope of the normal line?
-3.
-3/2. It's -3/2. Okay, they are perpendicular. The normal line and tangent line are perpendicular to each other, which means that the normal line and the curve are also perpendicular. Okay, so in here, what we're going to ask you to do is to find slopes of normal lines and also equations of normal lines. Okay, the process doesn't change because the slope of the normal line is the reciprocal and opposite of the slope of the tangent line. And what do the normal line, the tangent line, and the curve, what's the one point they all have in common? That point of tangency is identical to all three of them. They all pass through that. So here is a problem for you. You've got 6x squared plus 3xy plus 2y squared plus 17y minus 6 is 0. I want you to verify, verify that -1, 0 is on the curve. And then find the equation of the tangent line at that point, and the normal line equation. Whoops. So when I ask you to verify that a point is on the curve, what does that mean? Absolutely, that when I replace x with -1 and 0 with y, what should happen? Better equals 0, right? If it's not, then we can't do any of those things. Okay, so 6 times -1 squared plus 3 times -1 times 0 plus 2 times 0 squared plus 17 times 0 minus 6 is 0. Okay, what happens to every term that had a y in it? It's gone. Leaving me with 6 minus 6 is, you bet, 0 equals 0. Okay, -1, 0 is actually a point on that curve. Okay, which means that I can talk about that curve having a tangent line at that point and also having a normal line. How do I find the equation for the tangent line and a normal line? The equation for any line, what do you need? You need a slope and a point. Which one do you have already? You have the point. We know that it passes through -1, 0. Okay, we know that that's the point. What I don't know is the slope for either of those, but can I find them? Derivatives, absolutely. Okay, so let's differentiate. Find y prime. Okay, start with 6x squared. What's its derivative? 12x. Next one. How do you differentiate 3xy?
3y.
3y, okay. 3y plus
Y prime.
a little more to it than y prime. 3x, y, just 3x, y prime. Because what's the derivative of y? Just y. It's 1 times y prime, so we just need the y prime in there. So this is the derivative of 3x times the second function y, plus the first function of 3x times the derivative of y. Okay,
That's
so
using the product rule.
that's product rule. Yep. Plus, now go to 2y squared. For what? Y prime. Yeah, every time you take a derivative involving a y, make sure you multiply by y prime. That's chain rule. Okay, minus. Oh, it's plus. Lost where I was at. 17 y prime. What happens to the -6?
0.
It's gone and still equal to 0. Okay, keep it that equation because that's the only way we're going to be able to find y prime. So now we got to solve for y prime. In order to solve for y prime, what happens? These first two guys come over here, and what happens with the other three? You can factor out a y prime, so hopefully I don't lose anybody. Y prime times 3x plus 4y plus 17 equals -12x minus 3y. I factored out the y prime out of the three guys that all had it, and at the same time moved everything that didn't have a y prime to the other side. Now you almost have y prime. What's y prime in the end? -12x minus 3y over right there. That's just y prime. Okay? Now, y prime leads us to what? Slope of the tangent line. Okay? So, a classic notation, because now we're dealing with two kinds of slopes, is to use m with a capital T. Okay, this capital T means tangent, and it's the same notation that every Calc 3 book uses. They will always use a capital T for tangent. Is equal to the derivative evaluated at the given point. Okay? Notice that you need both the x coordinate and the y coordinate in order to do this. So what does this become? -12 times -1 with a 0 over 3 times negative 1 plus 0 plus 17. Once you plug those numbers in, it's now just a matter of finishing off the arithmetic. This is 12 over 14, or 6/7. Okay? So now we have the slope of the tangent line. Do we have the point? Yeah, that was given to us. Okay? The point is, so now my tangent line is what? Y minus 0 equals 6/7 times x plus 1. Or, to solve it like I would prefer that you wrote them, there's my tangent line, my y tangent. 6/7 x plus 6/7. Okay, now what about the normal line? In order to get the normal line, I need the normal slope. And for normal, we use capital N. How do you find the normal slope? Yeah, it's the negative reciprocal of your tangent, right? So this ends up being negative 7/6. Okay? So now my normal line is still y minus 0 equals negative 7/6x, 7/6 times x plus 1, or if you write it the way that I prefer that you wrote it, in slope-intercept form, my normal line is negative 7/6 y minus 7/6.
What's the minus 0?
That's the point slope form. It's the y coordinate, y minus y sub 1 equals m times x minus x sub 1. Okay, so I started with point slope form and then went to slope intercept. Okay, so there is those two equations. Nothing different from before other than now there's a lot more algebra that you actually do have to take into consideration in order to find y prime. So we're still using chain rule, and every time that you take the derivative with respect to y, you have to make sure that you put a y prime in there, because that's chain rule. Okay, y is some hidden function of x. That's the entire key to implicitly differentiating a curve, is to remember that we keep y as some function of x. We don't care what that function is. It's just some y of x, and I get to go in, take its derivative, and its derivative still calculates slope. It's opposite and reciprocal. Now we can talk about a normal.